Hey everybody, this lesson is transversals and parallel lines. And don't forget, all your lessons can be found at Mrmathblog.com, and this class is called Integrated Math 1. So this lesson right here, it's used a lot. It's one of the more important lessons it's on the SAT. I've been teaching an SAT prep class for about 20 years, and they're loaded with this section on here. I tell my kids to put their thinking caps on. This is an important lesson. So they all are, but this one especially. Our question is here: how can we prove and use theorems about angles formed by transversals that intersect parallel lines? Okay, start off with a couple of definitions here. Okay, so I see three lines right here, and then none of them are parallel yet. Okay, so when they are, then magic stuff starts happening. But here, a transversal is a line that intersects two or more other lines in different points. Okay, so right here, this line right here is our transversal right here. And so what happens with this transversal is it gives us all kinds of angles in here. There's 8 different angles in here, and they have special names. Okay. So corresponding angles are, one of them's on, I'm sorry, they're both on the same side of the transversal. And let's see, and they're on the same side of the intersectant lines right here. Okay, let's see if we can make sense of that right here. So let's deal with the left side of this transversal right here, and let's focus on angle 1 right here. Okay, now the corresponding angles is one is an inside one and one is an outside one. So like angle 1 is outside of these two lines right here. So the corresponding angle with angle 1 would be angle 5. I tell my kids, imagine if this line slides down and goes right on top of this line right here. Angle 1 would slide right down on angle 5, and angle 4 would slide right down on angle 8. Angle 2 would slide on 6, and then 3 would slide on 7. So those are all our corresponding angles right there. And that's how I abbreviate corresponding angles right there in my class. Okay, so just do a little angle symbol right there. Okay. And then we have these other things that are called same-sided interior angles. Same-sided interior angles, they're also on the same side of the transversal, but they're both inside, they're interior of the two other lines. So like 4 and 5 are same-sided interior angles. 3 and 6 are same-sided interior angles. Okay, so there's only two pairs on this picture here. So how I abbreviate that is SS int angs. Okay, so same-sided interior angles. So 4 and 5 are same-sided interior angles, and 3 and 6. Okay, and we have these other ones that are called alternate interior angles, and they are alternating on the transversal. 4 and 6 are alternate interior angles. 3 and 5 are alternate interior angles right there. Okay. All right, and then we have these alternate exterior angles. Okay, they alternate on the transversal. One's on one side, one is on the alternate side. That's why they're alternate. So, and they're exterior, like 1 and 7. Okay, or 2 is outside and it alternates outside with 8. So those are alternate exterior angles right there. Okay, all right, so that's going to lead us to what happens when we have parallel lines. Okay, so parallel lines are lines that are in the same plane, and they don't intersect each other. Okay, lines aren't necessarily parallel if they don't intersect each other. They have to be in the same plane, and I should have drawn a picture of this. But ask your teacher about skew lines, you guys. Skew lines are lines that they're not parallel, but they don't intersect. You know, like think of let's see, think of the corner of a wall where it meets another wall, and if you can think down the middle of those where those walls meet, there's a line right there. Okay, and then that line will never intersect, say, some other line on another. I don't know. It's hard to explain without a picture, but ask your parents about, or not your parents, your teachers about skew, S-K-E-W. Okay, those are lines that are not parallel, but they don't intersect, and it's because the key thing is they're not in the same plane. So parallel lines, they lie in the same plane, and they don't intersect. Okay, like this plane is this white piece of whatever flip chart right here, or white piece of paper, or your whiteboard in your teacher's room is a plane. Okay, and these red arrows mark the lines are parallel right there. Okay, you probably have seen that before. So line L and line M are parallel, and we write it like this with these two, looks like the number 11, really skinny long things next to each other. That means parallel. Okay, so when two parallel lines are cut by a transversal, lots of magical stuff happens, you guys. So same-sided interior angles are supplementary. Do you remember what supplementary means? It means they add up to 180. Okay, so 3 and 6 adds up to 180, and 4 and 5 add up to 180. So if you know the other one, you can subtract it from 180 to get one of the other ones there. So alternate interior angles are congruent. So 3 and 5 would be congruent, and 4 and 6 would be congruent. Okay, all right, and then alternate exterior angles are congruent. 2 and 8 are congruent. 1 and 7 are congruent. Okay, and then let's see. So corresponding angles also are congruent. So 2 and 6, since they're corresponding angles, they're congruent. 3 and 7 would be congruent, okay? 1 and 5, and then 4 and 8. Remember, corresponding angles are if the lines slide together, 4 would slide right down into the 8 position. Now, if these lines weren't parallel, then this magic stuff doesn't happen right here, okay? This magic stuff gets canceled out if these lines are not parallel. Most of the time we're going to be dealing with parallel lines, but if they're not parallel, they still are same-sided interior angles. They still are alternate interior, alternate exterior, and corresponding angles. They still are those, but if they're not parallel, then this doesn't happen. If they are parallel, then this happens. And the trick I tell my students is this: if you got parallel lines, if the angles look like they're congruent, then they're congruent. If they don't look like they're congruent, then that means they're supplementary. Okay, so look at 3 and 5. That's an acute angle. That's an acute angle. They're congruent. Look at 3 and 8. Even though they don't have a specific name, this is an acute angle, this is an obtuse angle. They're not congruent, so those guys add up to 180. They're supplementary. Hey, what about there's no name for it, but what about same-sided exterior angles, like angle 2 and angle 7? Okay, obtuse, acute, they're not congruent, so they would be supplementary. Okay, so same-sided exterior. Even though we have same-sided interior, there's no real true name for same-sided exteriors, you guys, like 2 and 7 or 8 and 1. Those are same side of this transversal. They're on the right side, and they're both outside, but they're supplementary. Okay, all right, so here we don't have parallel lines, so all that magic doesn't happen, but we can still name the angles. Okay, so name the pair of angles, angles 1 and 5. Those guys are corresponding angles, okay? Imagine if I slid this line over here, 1 would go over there. 2 and 8, okay? 2 and 8, they are inside, interior, alternate interior angles. Okay, 4 and 6. 4 and 6 are both outside, and they're on alternate sides of the transversal, so they are alternate exterior. 5 and 7. Do you remember this? This is from lessons, lots of lessons before. These guys are called vertical angles. Don't forget about those. Vertical angles are always congruent no matter what. Okay, 2 and 3. 2 and 3, these are from the last lesson. These are a linear pair. Those guys are always supplementary no matter what. Okay, and then 3 and 8. What are 3 and 8? 3 and 8 are same-sided interior angles, and since these lines aren't parallel, I don't know anything about those, okay? Okay, so in the figure, lines A and B are parallel. Find the measure of angle VTU. If the measure of angle PRS is x plus 40, and the measure of angle VTU is 2x minus 22. All right, well, let's mark the parallel lines. They're parallel. Let's put those angle measures in there. Okay, now, since those lines are parallel, then these alternate exterior angles are congruent. Okay, now, if they weren't parallel, I couldn't do anything, you guys. But they are parallel with the red arrows, and they told us they were parallel right here. So let's go ahead and set them equal to each other. So I'm going to go ahead now and add 22 to both sides. Subtract x from both sides. We get x equals 62. Now up here it says find the measure of angle VTU, not x. Okay, a lot of kids think they're done right here. So we got to substitute in x right here for 2x minus 22. So here we go. So we're going to go and plug that in, and we get 102 degrees. Okay. All right, let's try another one. So in this diagram, lines A and B are parallel again, so answer each. So it's given that this angle, PRS, is equal to, so here's the measure of angle PRS, it's 9x degrees, and the measure of angle WUV is 22x plus 25. Okay, so what are measure of angle PRS and RUW called? Okay, so that's what this says here. So PRS, so that's this angle right here, and RUW is this angle. Those guys are called corresponding angles, okay? All right, so this says angle RUW and angle something else are supplementary. So RUW, I'm going to guess WUV because it makes this linear pair. This angle and this angle makes this straight line. So that's what goes in right there. So that means they add up to 180 right there. Okay, so here we go. We're going to solve for x. Okay, so 9x, because remember, these guys are equal because they're corresponding angles right here, so you can slide this 9x right there. So then this 9x plus 22x plus 25 equals 180 right there, because I know these are supplementary, and since 9x equals this angle, then that means these guys are supplementary. Okay, now the trick is, that's acute, that's obtuse, they're supplementary right there, as long as the lines are parallel. Okay, so here we go. We're going to go ahead and add those x's to get 31x plus 25, and then subtract 25 from both sides, then divide by 31, and we get x equals 5. Okay, now let's substitute the value, because it says right here we want to find the measure of angle WUV, so we're going to substitute x into WUV right there. Okay, so when we do that, 2 times 5 plus 25 is 110 plus 25, or 135 right there. Okay, all right, so here, one more. In the diagram of this gate, the horizontal bars are parallel, so these are parallel, and then these are parallel also right here. Okay, so find the values of x and y and justify y. Okay, it's kind of hard to see, so I'm going to highlight these angles in red. All right, check this out. There we have corresponding angles, and since this line is parallel to this line, then these corresponding angles are equal to each other. So 12x plus 2y is equal to this 126. All right, now I'm going to highlight different lines now. So I'm going to highlight the top and bottom. Since the top and bottom are parallel, then this line is equal to this line because these are alternate interior angles. So 3x plus 2y equals the 36. Okay, so now we have this equals this equation, and we got this equation, so we can solve the system of equations right there. All right, well, these are already, I can subtract because we got 2y and 2y, so I'm going to subtract those two equations right there, and we get x equals 10. All right, and then we're going to find y. Just substitute it into any equation. I chose that one because it has smaller numbers, and we get y equals 3. All right, if you are in my class, that would be your assignment. Take care.